Hello and welcome to the Big Dumb Networking Dude channel. Today, by user request, we are going to be doing a video on how to configure a gateway load balancer within Azure to be utilized with the FTDv. Now, this is a pretty cool deployment method because we're able to now kind of treat the FTDv as a bump in the traffic. We don't have to do complex NAT. We don't have to change our routing. So if we have a public facing application, we simply just need to integrate that with the gateway load balancer, which then we would point to the FTDv. It's going to do some connectivity via VXLAN. That traffic is going to go right in there, do the inspection, come right out, and it's just a really simple and scalable solution that I hope you guys will enjoy and be able to take advantage of at a given time. Before we jump into the actual configuration, I do want to very briefly go over what the architecture is going to look like for this environment and for this demo, and then also kind of go over what the packet flow would kind of look like, and then we will jump directly into the configuration and knock that out quickly. So let's go ahead and look at the architecture right now. So this is a very simplistic representation of the environment that we are kind of going to be working in today. So from the Azure side, we have our FTD already deployed. I'm not going to deploy this again as part of this tutorial video. I have another video on how to deploy an FTDv in Azure, so that is already spun up and working. I'm not going to be doing this in this one, but we have our FTDv, we have an inside interface, we have our diagnostics interface or management, and our outside interface. The gateway load balancer we will be deploying inside the outside subnet. It's not a hard requirement by any means, but I think it's a bit easier just in terms of remembering where things are to kind of do it that way. And then we also have our application in which we are going to be connecting to. So as of right now, I do have a Kubernetes pod deployed. I've got an application that has like a little storefront on it. If that's something you're interested in looking at, Microsoft has a very well written out how to get that deployed. But this application also has an external facing load balancer where that public IP address is associated, and then that is what we're going to be hooking in to the gateway load balancer to be able to go into our FTD, do the inspection, and then get into our application after that is done. So this architecture, this solution is really good for north-south traffic. It does not do anything for east-west traffic. You can do that with this same type of deployment method, but it's going to take a little bit more. It's a little bit more complex because now we will be introducing probably an internal load balancer here where we'd be kind of forcing traffic in to do east-west inspection and back out, especially if you're dealing with a monolithic application where you might have a presentation, application, and database layer, and those things need to talk with one another. So we will not be covering that at all in this tutorial either. I just want to let you know that while this shines for north-south traffic, we can still use the same firewall deployed for this to do east-west as well. But let's look at the packet flow real quick. So starting out, we're going to have obviously our communication coming in from the internet. And before we had our firewall and gateway load balancer set up, it would essentially just go obviously internet to the public IP of our external load balancer, and then it would just go to whatever server that we have behind that. Once we introduce the gateway load balancer and the FTDs, what we're going to do is we have our traffic coming in to the public load balancer. We associate this gateway load balancer to that public IP. So that is going to get shot over to the gateway load balancer. The gateway load balancer is then going to send that traffic into the firewalls where we will perform inspection. You can do intrusion detection. We can have our file analysis, whatever the other features we want to turn on to do that inspection. And then once that is complete, it's going to send it back to the gateway load balancer, back to the public load balancer, and then on to its destination. And then basically for outbound traffic, if that's something that you need to allow to your application needs, it's the exact, basically the reverse order. So, you know, we've got the VMs would be initiating it. We'd bounce over here, go through inspection, bounce back, and out to the internet. So that is a quick and dirty on what the architecture looks like and how the traffic packet flow is going to be going. And now we will go ahead and hop right over into the Azure portal and get this configured. We're going to be starting off in the Azure portal and get the resources we need configured here, and then we will jump over to the firewall side of things. So before we get right into it, I do want to show you, so we do have this AKS, this Kubernetes service application deployed, and right up here you can see we are able to access it through its public IP address. Obviously, if you are doing this in a production environment or a heightened security environment, you're going to want to make sure you have, you know, HTTPS set up, a certificate deployed to this. But for this tutorial and this quick lab environment, this will suffice for now. So back to the Azure portal. I'm going to go in my Gateway Load Balancer resource group, which I created specifically for my Gateway Load Balancer. You can do it however you like, whether you want to throw it into another resource group. I just like to break my things out logically like that. So we'll say create a resource, go with load balancer. We will create a load balancer. I'll give it a name. We'll say Gateway Load Balancer YouTube FTDv. And we want this to be a gateway load balancer, which is already internal. We can't change that. And then tier regional. So then we go next to configure the front end IP. So add a front end IP configuration. Let's call this front IP underscore config IPv4. So select the virtual network that you want this to go in. It's going to go in my landing zone network. Subnet, I'm going to put it in the same subnet that my outside interface of my FTDv is in. It's not explicitly needed to do that, but for ease of management and rememberability, that's just us. I'm going to do it that way. So outside, I'm going to give it a static IP, and that is 10.0.34.25. Obviously, this will be with whatever you are doing for your environment. We're going to go ahead and save that. Then I'm going to go into the backend pool, and I'm going to add a backend pool. I will backend pool config, and you have the option to associate it with either a NIC or IP address. I like doing it by IP address. I feel like sometimes with NICs you can get some sort of what's the word I'm looking for, kind of conflicts. There's a possibility for conflicts. I just feel like, you know, IP is a little bit better. So protocol, this is VXLAN internal. We can leave all these to default right now. And then we need to select the resource in which this will be communicating to with the backend pool. So for us, that is the outside private IP of the NIC on the firewall. And we only have one firewall in this example. Typically, if you want HA, which you would have a second FTDv deployed, to which then you could then specify a second NIC for this. But for this purpose, for this lab environment, we're just going to leave it as is. But again, if you want to run this in production, then make sure you probably have some sort of high availability there. We'll go ahead and click save. Then we got to do the inbound rule. So this is pretty, we're going to add a load balancing rule. We really aren't load balancing here. Like I just said, we only have one FTDv, but we need some sort of health probe to be going so that we know we can pass traffic to this device, that since it's going to be up and running. So we'll just call this LB rule config. And because we really only right now have a single front end configured, a single back end configured, that's all we got to do there. And we got to create a health probe. So give it a name, health probe. And I like using TCP. So we'll go TCP, and then we can also do a non-standard port. So let's do 9443, and we'll click save here. We don't need to keep session persistence right now, and we will go ahead and save that. And that's about it. And you can add outbound, I mean, we don't need anything for this one, but if you needed to add outbound rules, you can add some tags if you tag your devices, but we're just going to go ahead and say review and create. Validation passed, so let's create. And it's going to go through the deployment. So we will wait a couple minutes for this to deploy, and then we have one more thing we need to do in Azure before we hop over to the firewalls. Deployment is complete. So come back here, go back to my resource groups, and now we need to associate this with the NIC of our, that is going to be receiving your external traffic. So in this case, it's going to be the load balancer of my Kubernetes environment. For you, that could be different. It could be a VM that has a NIC attached to it with an outside IP address that you can associate this gateway load balancer with. It's very dependent on the given scenario, but what you do need is you need something that does have a NIC. So go to front end IP configuration here, and then you will see an option for gateway load balancer, and we will associate the gateway load balancer we just created and click save. And that is all we really need to do within the Azure portal. But I will show you real quick what something else might look like. So let's go resource groups. We'll go. So let's say you just had a VM so like this Nextcloud VM that I used in previous videos. Let's say we gave that a public IP address, which we would come down here to IP configurations. And since this VM has a public IP associated with it, we can now associate that with the gateway load balancer if we wanted to. So again, this is depending on your application's deployment style. If you have a load balancer in front of it, that is the NIC that you want to associate with the gateway load balancer. If you have no type of load balancer and you have your NIC directly with a public facing IP address, that is what you want to associate with the gateway load balancer. So that wraps up Azure. Next, we are going to hop over and do our firewall configurations. All right, we are now over into our management system on how we are managing our FTDv in Azure. And again, this is going to be a little bit different depending on how you manage your firewall. So as I mentioned earlier, I'm managing mine in SCC. So that is Cisco Security Cloud Control. You can be managing with a cloud delivered FMC. You can be managing this with a on-prem FMC. You could be managing this with a FMC deployed in Azure, or you could be managing this through FDM. At the end of the day, the results are the same, but how it might look from, you know, a GUI and process perspective, it might be a little different. So there's that. So first thing we got to do, we got to create some objects. Let's start with that. So we'll go to objects, object management. I'm going to add an object, and then this is going to be for our Azure probe, the health probe that comes from our load balancer. And like death and taxes being an absolute thing within our lives, this IP address is an absolute for what you will be getting your health probes from. It is well documented, and until Microsoft changes it, this is the IP you need to have whitelisted to allow probes to your firewall. So we'll save that. And then the next thing we need to do is we need to add a new security zone. So we will add security zone, and we'll give it a name. We will call this, we'll just go VNI underscore zone. It is a routed, and at this given time, we don't want any kind of interfaces associated with this because it hasn't been created yet. We have not created the VNI. Well, will it help if I actually spell VNI? VNI interface yet. So we'll save this as is, and we'll come back and add interfaces in a couple steps. So after we do that, we need to go into our platform settings for that given device. So let's go to our platform settings. We're going to add a new policy. This is a threat defense. And we will call this, we'll say it FTDv Azure PP for platform policy. And it is going to be to our FTDv Azure. We'll save that. And let's go into HTTP access. We want to enable our HTTP server. This is going to be what our health probes are talking to. And if you remember, we use port 9443. And we probably want to lock this down a little bit. So we will say from, what do we call that? What did I call that? Azure probe. So we only want to allow it from the Azure probe to the outside interface. And we're going to say OK there. And we're going to save that. And then let's go in and create a access control policy for this. We will do it on the Azure firewall. And we'll say add a rule. We will say allow VNI traffic. And again, this, I'm just going to do an any here for testing purposes and kind of showing what can be done. You would obviously not probably want to have an any in a production environment, but we are going to, I'll throw that in above my starting rule. And what we're going to be doing here is we're going to actually be hairpinning this traffic. So we want to add this to the source and add it to the destination as well. And I am going to turn on logging at the beginning and end of the connection. Again, sometimes that kind of amount of logging can get a bit busy, but being that this is a lab environment, I'm only going to have this up for a little bit. And since we almost consider this from a troubleshooting standpoint, just to make sure we're seeing all the traffic that we expect, I'm going to have both on. So I'm going to apply that. I'm going to save that. And then I am going to go into devices again, so device management. We want our Azure FTDv. And I'm going to come over here to VTEP. And wait for that to load. And then we need to enable NVE. We need to add a VTEP. So we can leave this the same. So our VTEP source interface is outside. Our peer is the IP that we gave to that front end of our load balancer, of the gateway load balancer, that is. So 10.0.34.25, or whatever you give yours. And we're going to say okay with that. Let's save that. And we're going to come over here to interfaces. And then this is where we're going to add our VNI interface. And we can give it a name. We'll call it VNI Azure. Security zone. This is where we are going to give it the VNI zone. Go ahead and give the VNI ID a number that you would like. And then if you remember, we kept those default settings on the gateway load balancer side, and we just need to enter those into here. So the internal port was 10,800. Our internal segment ID was 800. Our external port was 10,801, and our external segment was 801. Go ahead and hit OK there. Save that. And now we should be ready to go ahead and deploy this to that firewall. So go ahead and hit deploy. And oh yes, we do get a validation warning. That is because I believe the IP address or the outside interface as part of this is trying to do ICMP to the gateway load balancer and does not get a response back, which that is to be expected. So we can go ahead and just ignore those warnings. Everything will kick off as expected. So deploy that. We'll wait on this and then check and make sure things are working as we expect. Now that's deployed, if you were following along basically verbatim of this tutorial, after that deployment, you would have saw your VNI was red and nothing was able to connect to it. And that is because I forgot a pretty critical step. As I was going through the configuration, there was a checkbox I forgot to hit, and that was NVE map to VTEP interface. We do need to click that. So sorry about that. If like I said, if you're following this step by step, go back in, check this, hit OK, and then because of that, you will need to do a deployment again. Again, apologize, but so that is needed. Now that we have that up, you can see our storefront is still available. You know, we're able to add things to the cart, navigate to our cart, so that is working. I do also want to show you I did deploy a access control policy to limit some of the connections down, because when I looked in my logs, I was getting absolutely hammered on a bunch of random ports because of that any rule that I put in there. But so you can see now I'm only allowing port 80 in and blocking all other traffic. So let's go into the logs just to make sure, you know, this stuff is actually passing. Before I do that, just to generate some more traffic, I do have a Python script over here that is going to just test some random ports. So I'll kick that off so we can look at that. And then we got to go over here. So as much as I do love security cloud control, I do kind of miss the way connection events are looked at in your typical on-prem FMC. And I also feel like it's a bit snappier there as well. So let's go ahead and look at the live log. So I'm over here in events and logs, events, and then I'm going to go to my live log, and it's going to go by the host name here, which is that FTDv that we have in Azure, because I've got other firewalls, you know, in my lab environment, and we don't want to see all this traffic. So this right here is my public IP. You can see we have blocks. That is that Python script running right now. But if we do try to hit this again, of course you're going to do that when I am in the middle of recording. There we go. So let's do this. We should see an allow. There we go. We got some allows on the port 80 from my public IP as well. So this is working as we expected. And as you could see, as part of this deployment, we did not mess with any NAT. We didn't have to touch any routing. We are basically just inserting this firewall into the path, into the communication flow path, so that we can do some sort of inspection on it. And again, you can get as granular as you want with this. If you want to, you know, do other different networks, if you buy, you know, different public IPs only allowing this, it's just, again, just a better way to go about inspecting this traffic up in the cloud, which is an area where you typically sometimes do not have the best visibility. And that's all I have for you. Pretty easy, but very effective solution. And like I said in the beginning, this was all because someone requested that I make this video. I don't think it's any secret. I kind of suck at coming up with content. So please, if you have something you would like to see, test it out, especially if it is Cisco based, if it's something in Azure, let me know and I can try to make a video on it. But in the meantime, you know, while I'm trying to think up new and exciting things, make sure you guys keep labbing and stay classy out there.
Oh, brother, this guy stinks!